Welcome back. So we were working on finding confidence interval. All right. So far what did we do? We found the critical value Z for which a certain confidence level is the probability that your standard score is between two symmetric numbers. Now here is something that is optional. It is an optional derivation of this particular equation. All right. So we have confidence level C. So far we found critical value Z sub C such that probability Z score is between negative ZC and positive ZC is C. This statement gives us information about the size of Z, but our question is about x bar minus mu. Remember, this was the marginal error that we want to control. Now, is there a relationship between Z and x bar minus mu? The answer is yes, since by the central limit theorem, x bar has a distribution that is approximately normal with mean mu and standard deviation sigma over square root n. So remember the formula to convert x bar to standard score. Z is x bar minus mu over sigma over radical n. That is the standard deviation of the x bar distribution. Okay, so Z is between these two numbers. So this fraction is between those two numbers. Probability of that happening is C. All right. You can multiply all the sides by the denominator. So negative ZC times sigma over radical n is less than sigma over radical n times the fraction. Well, that cancels the denominator and you're left with x minus mu is less than ZC times the denominator. Okay, the whole point of multiplying by this is to cancel the denominator and the denominator is gone. So this is equation 1. All right. Now let's use that equation. Now the margin of error, okay, of using x bar as a point estimate, okay. So I need an x bar, okay. So this is, okay. The margin of error or absolute error using x bar as a point estimate for mu is this. So this is called margin of error. Difference between mu and your sample mean. Take absolute value just to make sure you don't have a negative difference. Okay, so that absolute value of x bar minus mu is called margin of error. In most practical problems, mu is unknown, so you don't know the margin of error. So we instead calculate something called error tolerance E. Error tolerance serves as a bound on margin of error. Bound meaning the worst case scenario. The maximum margin of error is called error tolerance. It's given by this particular formula. All right. So okay. So what does that mean, right? I'm sorry. Okay. Where did this formula come from? Look at the previous slide. You see, we cleared the denominator. That quantity is the maximum error we allow ourselves. Okay, that quantity is the maximum error we allow ourselves. All right. So this is based because sigma over square root n is the standard deviation of the X bar distribution. So whenever X distribution is normal with mean mu, you are guaranteed this to be the deviation for X bar. Now, if X distribution is not normal, then according to the central limit theorem, you need large samples, at least 30. Then an X bar, this should be X bar distribution, yeah. So it is an X bar distribution is approximately normal with mean mu and standard deviation this, okay. So we are using materials from section 7.5 on central limit theorem. All right. So that tells me probability. Now all of this is from here. Okay. So what are we saying? X bar minus mu is between E and negative E. So negative E is less than X bar minus mu less than E. Let's understand this. Remember, E is called the tolerance, error tolerance. It is the maximum margin of error that we allow. Okay, this should be X bar. You can rewrite it. This is same as its equivalent. Okay, you might want to say multiply throughout by -1, then add X and so on and so forth, and you get this particular limit. Mu is between X bar minus E and X bar plus E. So probability that this happens is C. All right. So this particular interval is called confidence interval. Confidence interval. So what do we know? There is a chance C that the interval from here to here contains the population mean mu. So this should be X bar. Okay. There is a chance C that the interval X bar minus E to X bar plus E contains the population mean mu. We call this interval confidence a C confidence interval. What is a C confidence interval for mu? Is an interval computed from sample data in such a way that C is the probability of generating an interval containing the actual value of mu. Okay, so notice C is the probability of generating an interval containing the actual value of mu. In other words, C is the proportion of confidence intervals based on random samples of the same size n that actually contains mu. Okay? C is the proportion of confidence intervals based on random samples of size n that actually contain mu. So how do you find confidence interval for mu when sigma is known? What are the requirements? X be a random variable appropriate to your application. Obtain a simple random sample of a certain size n, from which you can compute the sample mean X bar. The value of sigma is already known, typically from a previous study. If you can assume that X has normal distribution, then any sample size n will work. If you cannot assume this, then you need a sample size of at least 30. Confidence interval is x bar minus E until x bar plus E. This is mu between these two numbers. Where what is x bar? That is the sample mean of a simple random sample. E is the error tolerance or the maximum margin of error. ZC, sigma over square root n. What is ZC? ZC is the critical value for confidence level C. C is the confidence level given between 0 and 1. Okay. So here we have an example. Let's come to this example in our next video. Until then, bye.